Okay, boys and girls, this is where we left off yesterday. Um, I don't know if you remember, but we got to some interesting presidential trivia. We said that Teddy Roosevelt was the youngest president ever because he took over for McKinley, who was assassinated. And so many of you, well, maybe one of you, is at least wondering why I have a picture of Teddy Roosevelt here. And that's because there is Roosevelt's corollary, and it's Roosevelt's corollary to the Monroe Doctrine. And what a corollary is it is an important statement derived from a theorem. And so Roosevelt's corollary was an addition to the Monroe Doctrine. It wasn't quite as important as the Monroe Doctrine. The Monroe Doctrine said, hey, Europe, you stay out of over here. And what Roosevelt added to that was, don't only stay out of here, but I'm going to have the power to police Latin America and the Caribbean myself, just to keep you out. So that was his addition to the Monroe Doctrine, and that's what a corollary is. It's an addition to a theorem, not quite as important as the theorem, but it's easily derived from that theorem. So let's look at a couple that we have in this chapter. Here's corollary 4.1. It says the acute angles of a right triangle are complementary. Well, since we just proved that all triangles have a sum interior angles of 180, then it's pretty easy to show that if you have a right triangle, that means it has a right angle. It would be easy to demonstrate that adding this angle and this angle together has to add up to 90, because 180 minus this 90 from there is 90. And then if you have two angles that sum to 90, we call that complementary. And so that's how I would prove theorem 4.1. Corollary 4.1. It's not as important as the angle sum theorem, but it's an easy add-on to it. Same idea down here with corollary 4.2. There can be at most one right or obtuse angle in a triangle. Well, if you had two right angles in a triangle, you're already at 180, and that would leave 0 for the third angle. And consequently, if you had two angles that were greater than 90, then you're already greater than 180. But the angle sum theorem says it has to be 180. So you can't do that. So again, this is an easily proven statement from a theorem, and we call them corollaries. Now again, your book will reference them by numbers like that, but I'll never do that. I'll just mark it wrong because I have no idea what corollary 4.2 is. I do know there's at most one right angle or one obtuse angle in a triangle, but I have no idea what corollary 4.2 is. So just like we do with theorems and postulates, don't use numbers. Just summarize their meaning if you're going to use them for proofs. Speaking of proofs, I have something very exciting for you. It's another kind of proof. We've written paragraph proofs where you just have to say in words what you're doing. And we've written formal two-column proofs as a way to organize. Well, a flow proof is yet another way to write a proof and another way to organize it. And this is really good if you're a visual type person. Remember how in two-column proofs I like to write my given and then what I learn, my given and then what I learn, my given and then what I learn? This is kind of the same idea. It links logically related statements together with arrows. So let's just say I have a picture like this. And I knew that line A was parallel to line B. All right? So that was what I would be given. So I might write A parallel to B. And I write the reason underneath. Uh-oh, don't slide. Like that. And then I write what I learned from that. So I might know that angle 1 is congruent, don't slide, to angle 2 because corresponding angles are congruent. So I learned that angle 1 was congruent to angle 2 from A being parallel to B, so I would connect those with an arrow like that. That's the idea of a flow proof. So that picture behind what you see is actually a flow chart, which looks a lot scarier than flow proofs are. So we don't have to worry about that. All right. But what you're going to do is you're going to write your statement in a box. You're going to write whatever justification you're using underneath. And then you relate. Oh, that's a neat trick. There we go. Maybe not. Well, I couldn't do this if I wanted to. But you relate boxes together with arrows. Okay, let's do one. That was terrible. Alright, so let's do a flow proof together. And hopefully the pin's going to work out for me this time. We're given that segment AB is congruent to segment DE. Those guys are the same. And AC is the same as DF. DF is there. We want to prove that BC and EF are the same. So this is really a proof from, like, was it chapter 2? We did those segments being segment relationships, I think. So this is from chapter 2, but we should be able to do it in our new format. So I'm going to start with a statement. AB congruent to segment DE. Alright, and put it in the box. And that was given information to me. So what do I learn from that? If two segments have the same length, then that means that the distance between those endpoints is the same. So AB is the same as DE. I learned that from the given information, and that's the definition of congruent segments. I have this piece of given information, that AC is the same or is congruent to DE. That was given. I have no idea why it does that. Alright, and what that tells me is that the length from A to C is the same as the length from D to E. Now, notice how I have connected the boxes. Okay. I have AB and DE being congruent, linked to AB equals DE. Move that a little bit. Looks a little better. Okay. AC being congruent to DE, this part over here. Alright, this information does not tell me anything about this, so I don't have them linked with arrows. This tells me this, so they're linked with arrows. This tells me this, so they're linked with arrows. I don't have an arrow from here to here because they have nothing to do with each other. Now let's look at the picture so we can keep going. I see that if I look at the picture, if I add the length from A to B, oops, got to write with something. Alright, if I add the length from A to B to C, then I would get the length from A to C. And likewise, if I go from D to E and I add that to E to F, then I would get the length from D to F. Now I can put these in the same box because this is the same idea. And this is the segment addition postulate. Now this box is unrelated to these other two boxes because this is true whether those are congruent or not. So they're not related information. Now let's come back to over what we learned. If I add the left side here, let's see, if I add this left side to this left side, that will equal adding this right side to this right side. So that means that AB plus AC equals DE plus, I wrote something down wrong somewhere. Oh, this should have been an F. I'm sure all you guys caught that the first time I did that. Whoa, put that up there. Ah, there we go, better. Okay, so I added the same thing to the two left sides as the same to the two right sides. So I use the addition property of equality, and I got that from here, and I got that from here. So I'll use arrows to relate that. So now if we look, we can, let's see, oh, hold on, I gotta pause this for a second. Okay, I had to pause for a minute because I had to think what I was doing, and then I realized what I was doing was not perfect. Alright, I was thinking I was adding the two together to make the big ones equal, but the big ones are already equal. So let's revisit this part. What I wrote here was true. It just turns out it's not necessary. I don't need that. So I'm going to erase this addition property. And hopefully you're all doing your math in pencil just like I am. Erase that part. Okay. Now, like I said, I started to do this proof. Just adding this together and this together makes the whole thing equal. This together makes the whole thing equal. I already know the long ones are equal. So from this step, since AC and DF are the same, AC and DF are the same, that means that AB, oops, got it right, plus BC is equal to DE plus EF. So what I did was I replaced this with this, and I replaced this with this in this statement. So I substituted using this statement and this statement. Those are the two that gave me this part. So think about that for a second again. Let's highlight it. Alright, I know that AC and DF are the same. That's what that says, even though it doesn't really look like it. That AC and DF are the same. And that was given information. So now if I look over here, I have AC and DF being equivalent to these two things. AC is the same as AB plus BC, and DE is the same thing as, or DF is the same thing as DE plus EF. So I'm going to replace AC with AB plus BC. I'm going to replace DF with DE plus EF. And that's how I get this statement. AB plus BC equals DE plus EF. And that replacement is called substitution. Now, I learned this statement here, that AB plus BC equals DE plus EF, from this statement and this statement. So that's why I have the two arrows going there. An arrow connecting that box, an arrow connecting that box. That's where I learned that information. This had nothing to do with this, although it will in a second. So there is no arrow connecting those right now, because this had nothing to do with that. So that's why flow proofs are useful, is that they show you how things are connected. Alright, so now if we look at this statement, we already see that A, B, and DE are the same. So if I do that, what am I left with? BC equals EF, which is kind of where I'm going. So that's all I have to do, is I'm going to have D, oops, let me do it this way. I'm going to have BC equal to DE, because I'm going to subtract that and that. I haven't had enough Diet Coke yet this morning. BC is the same as EF. Alright. And so I learned that from this step, where those two are equivalent, and from this step, since those are equivalent. and I subtracted there, and I also substituted. But if you leave the substitution part off, I won't be mad. But just so you know, and now I can be done. I can convert back to congruence because that's what I was trying to prove. Using the definition of congruent segments. And that's a flow proof, and I learned this from that. And yours can look a little different depending on how it lays out on the page, but it's just another way for us to organize our information and show how things are related. And there's our homework page. This is the correct assignment. If you look at this if you look at just the PowerPoint on Moodle, it will have the wrong one. But I've updated that this morning. So that's everything. So have fun. Thanks for watching.